So today you are going to learn how to calculate how much of the excess reactant is actually left over after a chemical reaction has gone to completion. So in the previous video, you learned that the limiting reactant is the reactant that's completely consumed, and the theoretical yield is the maximum amount of product that can be made in a chemical reaction, and that the excess reactant is the one where you have stuff left over. Okay, so now you're going to actually calculate how much of that stuff is actually exactly left over. Okay, so let's look at the problem. Here's a chemical equation. Remember, stoichiometry is not possible without a chemical equation. And um, two values have been given to us: the mass of calcium carbonate, which is 6.088 grams, and the mass of hydrochloric acid, which is 2.852 grams. It's been given to us, okay? The question is, how much of the excess reactant is left over? Now, the problem actually doesn't tell us which one is the limiting reactant and which one is the excess reactant, which means the first step in solving problems like this is to figure out which reactant is the limiting reactant. Figure out the limiting reactant and the excess reactant. So it could be calcium carbonate that's limiting, or it could be hydrochloric acid that's limiting. So we don't know until we actually do the problem, okay? So like any other limiting reactant problems, we have to do two mass-to-mass calculations, one with calcium carbonate and the second one with hydrochloric acid. So if you look at the chemical equation, you'll notice that there are, in fact, three different products. There's calcium carbonate, there's carbon dioxide, and water. So you have your choice in which product you actually pick to do this calculation. You can either go from grams of calcium carbonate to grams of calcium chloride, or grams of carbon dioxide, or grams of water. Whichever one you pick, it's going to let you figure out what the limiting reactant is. However, for both calcium carbonate and HCl, it has to be the same product, okay? So I'm going to select to go to grams of water because I already know the molar mass of water. It makes it easier for me. You have a choice of three products to end with. I'm going to pick water, but whichever product you pick, you have to end with the same one, okay? For both calculations, the ending has to be the same type of product, okay? So if I pick CO2, it has to be CO2 up here and CO2 down here, okay? Now, let's do these mass-to-mass calculations and figure out which reactant, calcium carbonate or HCl, is limiting. So we know, like any limiting reactant problem, the first conversion factor is going to be molar mass. So the molar mass of calcium carbonate, I already calculated it, is 100.086 grams of calcium carbonate. And since it's molar mass, the number that goes on the top is going to be 1 mole of calcium carbonate. Remember, molar mass is always for 1 mole. Then we have to look at calcium carbonate and water. Those are the two things I'm comparing for this dimensional analysis. There's 1 mole of calcium carbonate for 1 mole of water. That's 1-to-1 ratio. So that means 1 mole of CaCO3 goes on the bottom and 1 mole of water go on the top. Okay, so I want to cancel out calcium carbonate and I want to go to water. Now that I have figured out the mole to mole ratio between calcium carbonate and water, I just have to write the third conversion factor, which is going to be the molar mass of water, which is 18.02 grams of water on the top, because we want to end with grams of water, and since it's molar mass, 1 mole of H2O is going to be on the bottom. So let's see if our units cancel out. Grams of calcium carbonate, moles and moles of calcium carbonate, moles of water cancel out, leaving us with the unit that we want. That tells me my setup is correct. So now I just have to divide 6.088 by 100.086 and then times that by 18.02. That gives me 1.096 grams of water being made from 6.088 grams of calcium carbonate. Okay, now let's do the same thing for the second reactant, which is hydrochloric acid. So the molar mass of hydrochloric acid is 36.46 grams, and on the top I'm going to write 1 mole of HCl because it's the molar mass. Grams and grams have to cancel out, which means the unit that's remaining is moles. Then I'm going to compare hydrochloric acid and water. So I'm going to pick a different color, blue. Hydrochloric acid and water have a ratio of 2 HCl for every 1 mole of water. So 2 moles of HCl on the bottom, 1 mole of H2O on the top, because we want to go to moles of water and cancel out moles of HCl. The 2 is because there's a 2 as a coefficient here. Then the third conversion factor is going to be the molar mass of water, which is 18.02 grams of H2O over 1 mole of H2O, because we want to cancel out moles of water and go to grams of water. Now, grams of HCl cancel out. HCl cancel out, and moles of HCl cancel out, moles of water cancel out. That tells me that my setup is correct. So now I just have to divide 2.852 by 36.46, and that's divided by 1, multiplied by 1 and divided by 2, and then that's multiplied by 18.02. That gives me 0.704 grams of water. So 2.852 grams of HCl only produces 0.704 grams of water. So that means the smaller number of the two masses of water that's produced is going to be your theoretical yield, right? So theoretical yield is 0.704, and the reactant that produces that theoretical yield is hydrochloric acid, which means this is my limiting reactant. And if hydrochloric acid is my limiting reactant, that means calcium carbonate is my excess reactant. So we did a limiting reactant problem, and we figured out our theoretical yields, our limiting reactant, and our excess reactant. Okay, so the question is how much of this excess reactant is left over, which means all 6.088 grams of calcium carbonate is not used up. We have to figure out how much of that is left over, which is now going to be the second thing that we do. So we just did the first step, and now we're going to do step 2. So step 2 to answer this question is to figure out how much of the excess reactant was consumed. In order to figure out what's left over, we have to know how much was used up. And the way to do that is to actually do another mass to mass conversion, but there's something different in this one. We're going to start with the mass of the limiting reactant, which is 2.852 grams of HCl. But instead of going to a product, we are actually going to end with the mass of the excess reactant. And you might be like, wait, don't we already know the mass of the excess reactant? Isn't that 6.088 grams of calcium carbonate? And the answer to that is that mass is the available excess reactant. But this calculation is going to tell us how much of that 6.088 grams was actually consumed. Okay, so let's do this mass to mass. We need the molar mass of HCl here, so 36.46 grams of HCl on the bottom, 1 mole of HCl on the top. We have to look at the ratio between calcium carbonate and our hydrochloric acid now. So that's 1 calcium carbonate for every 2 moles of hydrochloric acid. And that's what's going to be over here, 2 moles of HCl for every 1 mole of calcium carbonate. And then the third conversion factor is obviously going to be the molar mass of calcium carbonate, which is going to be 100.086 grams of calcium carbonate. And on the bottom, it's going to be 1 mole of calcium carbonate. Now let's see if our units cancel out, and then we'll know if our math is correct. Grams and grams of HCl, moles and moles of HCl, moles and moles of calcium carbonate. Now let's calculate and figure out of the 6.088 grams, how much was consumed, okay? So 2.852 divided by 36.46 divided by 2 times 100.086 gives us 3.914. See, it's a different answer. So this is grams of calcium carbonate that was actually consumed. So when you react 2.852 grams of HCl out of that total 6.088 grams of calcium carbonate, only 3.914 grams of calcium carbonate is actually used up. This is the amount of excess reactant actually used up. So that means if we subtract this amount from the original 6.088 grams, we'll know how much of the excess reactant is left over. So that's going to be 6.088 grams minus 3.914 grams. That gives us 2.174 grams of excess reactant left over. Okay, this is step 3, the subtraction. Okay, so this is original total mass, total excess reactant minus used excess reactant gives us leftover excess reactant. Okay, so 3 steps to figure out the amount of excess reactant that's left over.